everything going? Okay. Hey, Denny. All right, so in our first edition of Houston's Academy, we're going to go over the problem number 41, the problem with the lawnmower. So in this problem, we got this girl. She's mowing the lawn. She's pushing down on this lawnmower with a certain force, and the lawnmower has a certain weight. And the problem's asking two things. One, how fast does the lawnmower accelerate? And two, it's asking what is the normal force being applied to the mower from the ground. Okay, so the normal force is going to be the force. You got this force happening right here. You got this 25-kilogram mower that's pushing down on the ground, and you also have her pushing down on the mower itself. So the mower is not sinking through the ground. So of course that means by Newton's third law of physics that those two forces are going to be equal and opposite. So whatever force the mower is pushing against the ground, the normal force is that force that the ground is pushing back against the mower. And those two forces are equivalent. So again, two things we're looking to find here. The acceleration of the mower as it moves forward, as she pushes on it. And two, the force that the ground is pushing up against the mower to counteract the force that the mower and the girl is pushing down on the ground. Okay. So in this problem here, we got this girl. She's pushing with the force of 30 newtons. This force is coming down at an angle. She's doing this with a mower that weighs 25 kilograms. So this is our visual here. Hopefully you have this visual in your mind because I'm going to erase this real quick to give myself some more space. So this is our girl and this is our rough sketch. And if I were taking a quiz or an exam, I probably would have drawn something similar to that, probably not with the grass. But on my quiz paper, just a quick, so I got a quick idea, visual picture of what's happening in the problem. All right, and then what we do is we're going to convert this to a triangle and work out some geometry. So let's just draw the triangle of what we're looking at here. We got the ground here. We got a 37-degree angle that she's pushing down on at a force of 30 newtons. Now we're going to square this triangle off to make it a right triangle so we can figure out the other sides. Alright, so now what we want to do is we want to figure out, we're going to break this force down into X and Y components, into horizontal and vertical components. Guys, quiet. So this is going to be our X component, and this is going to be our Y component. And I just always use X and Y because of our old graph here. You got your X that go horizontal, and then you got your Y's which go up and down. So I just keep that consistent. For all my problems, I always call the Y the vertical and the X the horizontal, just for consistency purposes. All right. So in this, we're going to try to find the X. Okay. We're going to use some trigonometry here. We're going to say that X is this line here. So X equals, okay, X is the adjacent angle, or the adjacent side to that angle. So of course we know from SOHCAHTOA that it's the cosine that we're looking for, the adjacent. So X equals the cosine of 37 degrees, and the cosine of the angle is equal to the side adjacent over the hypotenuse. So that's going to equal X over 30. So to find out what our X force is, we're just going to solve this equation. We're going to do so by multiplying both sides by 30. And that is going to cancel those two out. And then we're going to multiply the cosine of 37 by 30. Okay? And when we do that, we are going to find out. All right. So when we solve this equation out, what we're going to do is we're going to plug in 37, hit our cosine. We're going to find out that that's 0.7986. So we're going to then multiply that number by 30, and that's going to equal X. So multiply by 30. X equals 23.9 something something. I'm going to just call it 24. So X is equal to 24. I'm going to take that 24 and I'm going to put it right here where X equals. So this is 24, and it's 24 what? What are we measuring here? We're measuring a force. We're measuring a force that's going horizontal. The force is, of course, measured in newtons, just like the force that we originally were given. Alright, so that's how we're going to find our X component, which we just found. Now we want to find our Y component. Y is going to be equal to the sine, because it's opposite. the sine of 37 equals y over 30. The sine of the angle equals opposite over hypotenuse. The sine of 37 equals y over 30. So we're going to do the same thing. We're going to multiply both sides by 30. These will cancel. So we're going to multiply the sine of 37 by 30. And that's going to give us what y equals. So if I say 37 sine, that equals 0.6018. And we're going to multiply that by 30. That's going to give us 18. Wait, James. Okay, give me a minute. So y is going to equal 18, and we can put that right there. You know, we can always double check our figures by using Pythagorean's theorem. Y squared, a squared plus b squared equals c squared. So if we square 18, that's 325. And if we square 24, that's 576. So the sum of those two numbers is 901. Take the square root of that, it's 30. 30.1, it's got a fraction on it because I've been rounding here. But the point is that this checks out. This is a good triangle. All the numbers match out. So our y force, our force going down is 18. Our x force is 24. Okay, and again, just what do these represent? These go back to the girl with the lawnmower. So she's pushing down with a force of 30 newtons. Of that 30 newtons, 24 newtons are going in this direction. The force going horizontally of that 30 is 24. The force going down is 18. Okay, so that's an important thing to understand what you're looking at here. You're looking at a total force of 30 going on an angle, and we're breaking that down between what's going horizontally and what's going on vertically. Okay, so it's 18 vertical and 24, but we're only figuring out what force she's imposing on the lawnmower. Okay, I'm going to pause real quick. I'm going to erase the board, and then